All right, we are in pre-calculus, doing AP calculus work. Lesson 2-3, general power chain rule. Queries hand, objective. Chris.
Use the chain rule on the general and power houses.
Yep, just general house and powerhouse. It's hard to see, yeah. Okay, so saying the derivative different ways. So if I take the derivative with respect to x of u, I call this thing du dx. And again, you can either pronounce it du dx or you can say the derivative of u with respect to x. Someone do this one. How do I say this and then how do I write it simplified?
I got it.
How do I say it? Go for it. Well, dv over dx, but how do I pronounce this thing to begin with?
I forgot.
Go for it, Emma.
Is it a sentence like the derivative of v with respect to x?
There it is, yeah. So go, Chris and Eva both get XP. There it is, derivative of v with respect to x.
What do you mean? I totally
Participating, please. And then finally, how do I read this and then change it into a fraction?
d of x.
So I need a quiet raised hand, please. Quiet raised hand, how do I read this thing? The derivative with respect, something, something. Who wants to give it a shot? Andrea, go for it. There it is. And then how do I write it as a fraction? And what is anything divided by itself? 1. Oh, hey, look at that. We were taking the derivative with respect to x before of x, and we were getting 1, and that's kind of another way of approaching the problem. All right, so here is the general chain rule. Every single time, and Gio and Stego, you guys can do this one too. Do either of you two want to give it a shot? It's doubter, something, something. There it is. Write it out. This is, I'm going to do it 2 different ways. We'll do one above and one below. The formal way in the textbook looks like this, and it's gross, but you do need to copy down. It's f prime of g of x times g prime of x. That is the formal rule that you would see in a textbook. Don't hit Fiona. Yeah, let's not. The easier way of remembering this is it's doubter. Doubter stands for the derivative of the outer times dinner. Now we're talking about dinner. Dinner is the derivative of the inner. Most people, when they make mistakes when it comes to derivatives, when it comes to chain rule, is they forget their dinner. Don't forget your dinner because you will starve. It's always doubter times dinner over and over and over again. You guys have been practicing finding outer and inner. Today's the day where you actually take the derivative of those and apply it to actually apply the chain rule. So again, if you go to college and you say, oh yeah, do you know how to do doubter times dinner? They're going to give you a weird look and they'll say, what are you talking about? But if you say, oh, do you know how to take chain rule? They'll be like, oh yes, I know what you're talking about. Chain rule is the industry standard. Everyone in China, in India, everywhere else, they know chain rule. They don't know doubter times dinner. That is our own personal rule for the class. All right, so again, outer is just going to be f of whatever. Inner is going to be g of whatever. And then your inner is going to be x in this case. There's x. So let's take the derivative of the outer. If the outer is f of something, what is doubter? F prime of something. So if inner was g of something, what is dinner? Shout it out. Thank you, Gio. G prime of something. And if inner is x, what is your dinner inner? What is the derivative of your inner? Come on, derivative of x. You guys got this. Derivative of x. Derivative of x is what? 1. There it is. All right. Whew. So eventually you should end by multiplying by 1. That is the spot at which you say, okay, I have now found all of the derivatives. I'm done. That's like the end point of chain rule. All right, so let's give it a shot. Here's my function. I'm going to take the derivative of 2f of 3 of x, which is kind of a, I'm in general house here. I know I'm in general house because I have a letter, f of something. And I kind of ruined that for you, but let's see if someone can regurgitate. What house am I in? Quiet raised hand. Quiet raised hand. What house am I in? Stego. General house. Why am I in general house, Stego?
Because you have a constant? Yeah.
The f, yeah, you have a letter. A general function. All right, so someone give me the outer. This is what you were doing for the homework on Friday. What is the outer? Quiet raised hand. Who's got this? Fiona. 2, just f of blah. We're going to take the derivative in a sec. What is the inner? Quiet raised hand. Geo. 3x. Are we all okay on identifying outer and inner? Give me fist of 5 really quickly. Outer and inner, the homework on Friday. How well can we do the stuff up to now? Identifying house. I'm getting 4s and 5s all around. All right. So then we're going to go to doubter. Now I'm going to take the derivative of the outer. Tell me what I got. Quiet raised hand. Who's got this? Take the derivative of 2f of blank. Who's got it? Gio, you have your card turned in like 3 times already. Teflon.
This is probably wrong, but 2f prime.
You are correct. 2f prime of whatever. And what about dinner? If inner was 3x, what is dinner? The derivative of that. Who's got it? Chris, go for it. Derivative of 3x.
3.
There it is, 3. So then I combine them. I come back up here to the very top and I say, okay, if I'm taking the derivative of 2f of 3x, I do doubter times dinner. Doubter was 2f prime of whatever. 2f prime. And now we actually have to put the whatever in there. This blank spot is always filled by your inner. So it's going to be 2f prime of the original inner, which was 3x. Again, you want to think of taking chain rule or doing your dinner, your doubter times dinner, as kind of like cracking in a nut. You've taken off the outer layer, or like peeling an onion. You've taken off that outer layer. I can't touch that inner layer because it's being protected by this f prime. I've taken the derivative. Now I can do dinner. I multiply by dinner, and that's times 3, and I can simplify that. When I simplify, I just get 6 f prime of 3x. Again, doubter times dinner, doubter times dinner, doubter times dinner. All right, we're going to move on to example number 2. We're doing the same thing. We're identifying the house, the outer, inner, doubter, dinner. All right, so first of all, if I'm taking the derivative with respect to x of 2 times the quantity of 4x plus 1, quantity to the power of 3, what house am I in? It's in the title. Look at the title of your notes. What house are we in? Teflon.
General.
Good guess. It's the other one. Look at the title. There it is. Powerhouse. What is the outer of the powerhouse? I only have one hand. What is the outer? Stego.
2 parentheses to
There it is. What is the inner? Eva. There it is. 4x plus 1. Now that we have the outer and inner and the house identified, let's go ahead and take the derivative. What is doubter? Again, this 3 is going to come, multiply down in front, and then it goes down to power. That's how I deal with powerhouse.
So wouldn't it just be 2 squared roots?
No, this 3 comes down, and I multiply by 2, 3 times 2. So who's got it? Quiet raised hand. Chris? 6, parentheses, 2. Good. Thank you. What about dinner? What is dinner?
Hey.
Gio, what is dinner? 4. There it is. The derivative of 4x plus 1 is 4 plus 0, or just 4. So then I come back up here and I say, well, if I take the derivative, I'm just multiplying doubter by dinner. Well, here's doubter. Doubter was 6 in parentheses of something squared, and dinner was 4. Doubter times dinner. But I need to actually fill in the inner here. It's always, if you come back up here to the textbook definition, that g of x is untouched and it goes inside your derivative of the outer. So that inner, this 4x plus 1 is going to come right here, and I'm going to rewrite that as 4x plus 1. 4x plus 1. And then I have to simplify this just a tad, and I can say this is 24 quantity 4x plus 1 quantity squared. So I've done an example of powerhouse, an example of general house. Give me a fist of 5 so far before you touch the hard homework. How are you feeling? I'm seeing 3, 4, 5, 4, 4, 4, and Geo, you're at a 5. All right. Good luck on the homework.